In this example, I want to sketch the graph of this equation here. So let's take a look at it and see what we're going to get. Well, if you notice, I have a y squared term and I have an x squared term. So that means it's going to be a circle, ellipse, or hyperbola. And in this case, I have 4y squared minus 1x squared. So notice, one of the squared term is positive, one is negative. Therefore, this looks like this is going to turn into hyperbola. And we need to see how it's going to start off. Well, if you notice, the y squared term is positive, the x squared term is negative. So that makes it look like it should open up and down. That's what happens when the y squared is positive, as long as when we get it in standard form, this number on the other side turns into a positive 1. So we're going to complete the square to see what this turns into. But for now, we think it is a hyperbola. And we think it is going to open up and down. So that means I'm going to get y minus k squared over a squared minus x minus h squared over b squared equals 1. So if it turns into that format, with this being a positive 1 right here, then this one is going to open up and down because the y term, the y squared term from here is going to be the positive 1. So remember, be careful on these. Where is the center? Well, since the y is first, it's going to be still the k, the opposite of this number is going to be the y coordinate, the opposite of this number is going to be the x coordinate. So be careful when you get to that point. So it looks like the center is going to be at hk, and we think it's going to open up and down, so it's going to look like a hyperbola that opens up and down like that. So let's complete the square and see what happens. So remember, to complete the square, we write the y terms together. So I'm going to write 4y squared minus 16y, and I'm going to put plus a blank because I know I'm going to have to add something there. Plus, now I need my x terms. So I'm going to put negative x squared minus 2x plus another blank equals, remember, the 11 we want on the other side, so I'm going to subtract 11, and then I'm going to have to put plus a blank plus a blank. So we're not ready to complete the square yet. Remember, to complete the square, the coefficient of the squared term has to be plus 1. So what I'm going to have to do here is factor a 4 out of these two terms, and I'm also going to have to factor a negative 1 out of these two terms. So 4 times the quantity y squared minus, 4 goes into 16, 4y, plus a blank. Now I'm going to factor from here, I'm going to factor a negative out. So we don't like to put plus a negative, so I'm going to have minus. And just to help out, I'm going to put a 1 there because I'm factoring out a negative 1. What is that going to do to these two terms here? It's going to change the sign in the parentheses. So I'm going to x squared plus 2x plus a blank equals negative 11 plus a blank plus a blank. So now we're ready to complete the square just like we've done before. So we're going to take, for the y's, we find the b term. Here's the b term, negative 4y. So we take b, which is negative 4. We divide it by 2. Negative 4 divided by 2 is negative 2. And then we're going to take that b over 2 term, and we're going to square it. So I'm going to get negative 2 squared is 4. So 4 is the number that I'm going to add inside that parentheses. So now be careful. What have I really added to this side? I've added a 4 times 4. So I have to add a 4 times 4, or 16, on the other side too. So what do I get in here? So I'm going to have 4 times the quantity y minus 2 all squared. Remember, the b over 2 term is the number that comes in here with the parentheses. And don't forget, double check, if you square this in your head, do you get these 3 terms here? Yes. So now we're ready. We've completed the square on the y. Now we need to go and do the same for the x. So on the x, what is b? B is plus 2. So I'm going to take b, divide it by 2. So 2 over 2 is 1. And then we take that b over 2 term and we square it. What is 1 squared? 1 squared is 1. So I'm going to add 1 inside that parentheses. But be very careful with this one. What have I really added to this side? I've added negative 1 times 1. So really, I have subtracted 1 from the left-hand side, and so I must subtract 1 from the right-hand side. So be really careful to make sure you're subtracting the same number from both sides. So now we're ready to complete the square. So down here I have minus the quantity x with something all squared. What goes in there with the x? The b over 2 term. So it's going to be x plus 1 all squared equals, now we need to add this number on the other side. So I have negative 11 plus 16 and minus 1. So what does that turn out to be? That turns out to be negative 11 plus 16 is 5 minus 1 is 4. So the left-hand side stays exactly the same. Should just rewrite it. And now we're almost done. So let's just scroll up a little bit, give ourselves a little bit more room here. And the last thing we have to do is we need to get a 1 over here. So I'm going to have to divide both sides by 4. So I'm going to divide both terms on the left and the right by 4. So these reduce on the left-hand side. I'm going to get y minus 2 all squared, but even though that is reduced, I'm going to write it over 1 minus x plus 1 all squared over 4 equals 1. So this is going to be a hyperbola. We know it's a hyperbola, and it's going to open up and down because the y squared is the positive. So it's going to look like that. And this is if you're ever asked to write it in standard form, this is the standard form of the equation. But I also want to rewrite this. Numerator stays the same. The denominator I'm going to write as the square root of 1 is 1, so it's 1 squared minus x plus 1 all squared. 4 is 2 squared, which equals 1. And that is going to help us when we actually graph this equation. Okay, I've taken the information from the previous slide. Here's the equation I'm trying to graph. And we wrote it here in standard form. And then at the last step, I just took these denominators, 1, and wrote it as 1 squared, and 4 as 2 squared. Now we need to find the center of this hyperbola. And be very careful with this because the center is at, notice, the opposite of this number is 2, and a lot of students say the x-coordinate of the center is at 2, but notice this is the y-coordinate of the center is at 2. The x-coordinate of the center is at the opposite of positive 1, which is negative 1, so be really careful on that. So when we graph this, we're going to graph the center first. And remember what we talked about before is since the y squared term here is going to be the positive one, this is a hyperbola that's going to open up and down. So we're going to graph the center at negative 1, 2. And to get these 2 points on the hyperbola, the vertices, we're going to have to go up and down 1 unit, so I'm going to have to go up and down 1 unit from the center. And then also this number here is going to help me because I'm going to go out left and right 2 units, and that will allow me to draw my little box to be able to graph in my asymptotes. So I think we're ready to graph it. So first I have to graph my center that is at -1, +2, which is right there. And now to get my vertices, remember we go up and down 1 unit because this one opens up and down. So I get 1 point here and 1 point here, which is actually on my hyperbola. But before I do anything else, I need to graph my asymptotes. So remember to find the box. I've already gone up and down 1 unit. Now I need to go left and right 2 units. So I'm going to go left and right 2 from my center, and that allows us to graph in our little box. And from that box we can graph in the asymptotes by joining this to this. So our asymptote is going to be a dotted line going through here. And there's another one going to go through here. I'm going to put it on pause so I can graph them. So now I've drawn in my asymptotes. As you can see, they are the red dotted lines. And all I have left to do is to graph in the actual hyperbola. Remember, here's one of the vertices, so it's going to approach this asymptote. It's going to come in and then approach this one. And the top part is going to look like this here. And let me put it on pause again. So I have graphed in my hyperbola. Notice it goes through this vertex and this vertex here. Starts out close to this asymptote, comes on in, goes out close to that asymptote. And the same thing happens up here.